Okay, let's take a look at number 6 here in section 10.4. We're going to determine the convergence or divergence by any method that we have introduced up through section 10.4. So for this series is n goes to 0 to infinity, -1 to the n times n over the square root of n squared plus 3. Well, first of all, looking at just the a sub n, or the absolute value portion of this, let's just take a look at that for a minute. If I look at the a sub n without the sign changer, what's the limit as n goes to infinity of that? Well, I can divide numerator and denominator by n. Up top, I get 1. And again, n is the same as the square root of n squared for n greater than 0, which it is. And so I can divide this by the square root of n squared. So n squared divided by n squared here, this becomes 1. And then 3 divided by n squared as n goes to infinity, that goes to 0. And so this limit is 1, which most of you probably knew already. So if I was taking a look at see if this was absolutely convergent, I know it would not be absolutely convergent because this limit is 1 and it's not 0. And therefore, by the nth term test, the series, absolute value of this series would be divergent. But our series has a sign changer on it. However, since this limit is 1 for our series, right, these values that we're adding up for large n are basically alternating between what? Either +1 for any value of n being even, right? This is a positive quantity, +1, right? So for those values, they're always 1. For the odd values, they're getting closer and closer to what? -1, right? For odd values, this is negative. And so because of that, this limit does not exist, right? The values just keep bouncing back and forth between -1 and 1. And so our series also, we can say now, diverges by the nth term test because this is not 0. Okay, so nth term test is our friend if we can show the limit as n goes to infinity of a sub n is not 0, as we can in this problem.